So I love interdisciplinary collaboration, and if you think about some of the hardest problems, they're at the boundaries of different disciplines and honestly different entity types. So now we're doing data science, we're doing machine learning, we're doing optimization under uncertainty, and we're doing economics and market design.
What we've been doing is looking at the way you search for materials. If you look, there are around 50,000 inorganic compounds that are known. I think there was, at most 50 to 100 that have been tested. Really, have been tested as solar. Are we missing anything? It's likely that we're missing anything. Between 50 and 50,000, yeah, there are out there very, very good solar materials. And this is the approach we do. We start with candidates, and we compute these properties. Before making them, we just compute, is that material going to have a high current lifetime? Is it going to be absorbing light the way we want? And so we've been running this, and we're actually bringing more and more AI in this, which
especially when you are looking at security critical problems, you have to really get understanding why the AI is giving you that prediction. Is that prediction reliable or not? How you are going to explain that? For me, I'm working with a lot of utilities or vendors so that they can give me the problems. It should be problem-driven type of solutions where you are able to tailor your AI solutions for those particular applications. You can do pilot or proof of concept studies with them so that they gain confidence.
I think this has the potential of taking that deindustrialization impact that we saw times 10, times 100. And I don't think we're having the right conversations, sort of educationally or politically, to get ourselves ready for what's already underway.
If your values are energy security, affordability, reliability, there's an ecosystem that can be supported through good policy. So policy is at the core of catalyzing the whole ecosystem.
It's a game of how rapidly you can remove that carbon before it gets oxidized by bacteria. So the big picture is to mimic processes at scale through clay minerals, and our goal is, of course, to remove over 3 billion tons of carbon dioxide within 10 years.
And it is not that widely understood that organic biofuels, in spite of the fact that you're putting a carbon molecule on the vehicle, organic biofuels have great potential for carbon capture. And cellulosic biofuels with carbon capture can be minus 150. That is, you actually save CO2 the more you use. Yep. You remove CO2 from the atmosphere.
If you go back decades to when the oil crisis of the 70s, a lot of the technologies that were incubated out of that were the building blocks for everything from the fracking revolution to our now greatly increased capacity to understand the potential of geothermal.